Hey, welcome back. So today we're going to be talking about video. So if you're following along at home, that would be page 44 of the syllabus with the current 2008 version. And we're going to be talking today fairly in depth about really one of the most important parts of multimedia. So when most people think about multimedia, they do think about video or anything with moving pictures, although multimedia, as we know, could be just graphic design or still design. When we're going through video, keep in mind that this is often a favorite of questions, so you'll often get asked a lot about file formats for video, what sort of video that you would use, problems involving sound and video together, things of that nature. So this is a lesson that you really want to pay attention to. So breaking it down first, there are two main types of video. So you've got analog video and you've got digital video. So analog video really goes back to that whole film strip idea. So you might have 16mm film, 8mm film, Super 8, various other types of film strip that works the same way as a camera does. So there is a negative which is exposed to light in reverse, and that prints an image in reverse, or a negative. That negative is played at whatever frame rate it needs to be played at to simulate movement. That's the way that it works. So you might play back at 30 frames per second, you might shoot it at 30 frames per second, and then it would show real life. So you can think about that the way you would think about an old film camera. The only difference between an old film camera that takes still pictures and a movie camera is a movie camera takes a whole bunch of them in quick succession. When we talk about digital video, it really becomes more of a light sensor, same as a regular camera, that takes multiple frames per second. So when we're talking about analog, we talk about those old film cameras that nobody really uses anymore except on professional film sets due to the expense and the difficulty of getting it processed. It can be very, very expensive. For example, when I've shot Super 8 in the past, 3 minutes of film will cost upwards of sort of like $150 Australian to get processed, compared with what I bought a 64 gig SD card the other day for like 50 bucks. So that can hold a couple of hours of footage, higher quality. So you really only shoot film now as an amateur if it's something that you're really passionate about or something that you want to work with for effect, especially because you usually end up converting it to digital to edit it anyway. So, you know, you could just slap an effect over the top of it and get an approximation that most people wouldn't know the difference about, and it's fine. Okay, so when we move on to file size considerations, so video is massive in terms of size compared to most other multimedia applications. So whereas a picture will be megabytes, a video will tend to be gigabytes in size. So when we work it out in terms of file size, the first thing you need to think about is frame rate. So if we understand that all video is just a series of still images one after the other, then the more frames per second you have, you could understand the bigger the file size would be. For example, something that's 30 frames per second would obviously be roughly half the size of something that's 60 frames per second if all of the other factors were the same. So you've got that sort of thing in there. So your frame rate is obviously going to be something that contributes to the size of your own video. The next thing that you might talk about is image size. So if we're using, say, 4K resolution for our images, then we've got a large area of pixels. It's a very big actual picture. If we're using something that's a much smaller resolution, then it's a smaller picture once again. Bring it back to images. The bigger your image, the bigger the size. So when we combine those two things together, the bigger each individual frame, and then the amount of frames per second is going to influence the final size of your video. That's pretty obvious and that's pretty evident. As well, once we get to color depth of each individual frame, we can see that that would also affect the ending file size. So if we used a bit depth of 1, so we can only show the two colors black and white, obviously that would be much smaller in file size than the 32-bit image. You have a 32-bit image running at 60 frames per second in 4K resolution. It's going to be very, very large over the course of like a 3 or 4 minute video. You're talking several gigabytes. And if you've ever used something like After Effects and exported it with the animation preset on, which allows for no compression, you're going to see sort of 4-minute videos that are 30 to 40 gigabytes in size. They're just massive. So when you try and view them as well, the computer actually has a hard time viewing them and has to convert them using QuickTime if you're using a Mac before you even open them up. So it's something that you've got to think about with video. We've pretty much gotten over file size considerations with images at this point. It doesn't really matter. They can download pretty quickly. Video, we're still in 2019 at the point where on some connections, really high quality video can be really slow. And especially if you're looking at things like streaming rather than downloading video, which we'll get to maybe in another lesson, it's something that you really need to think about. So then we talk about compression, okay? So compression, once again, we've got lossy and lossless. Once again, with lossy, we throw out data. So lossy video codecs are MPEG-1, MPEG-4, and one that nobody uses anymore called Real Video. Lossless, we don't lose quality. It's stored later. When compressed, we can get back to that original file. So MPEG video compared to MPEG-1 and MPEG-4 is a lossless format, but they don't save as much space. We use the lossless compression algorithm, okay? So how do we losslessly compress a video? Well, we may make the frame smaller, so we can actually change the size of the video down. We can also just run an algorithm which compresses the still images within the video. We can do lossy stuff like merging together colors. So it's basically the same thing as the things that we've already covered. You can take all of those ideas about image and audio and the compression from them, and you can apply them to video, because what is video but a collection of images and audio put together? So that's fine. Let's talk about the difference between video and animation. So video starts with a continuous analog event. So you've got someone legitimately acting on screen, running on screen. Let's use that as an example. What we do when we film something with a digital or analog video camera is we take that continuous event and we break it down into frames. Then we play those frames back and we get movement. So what we've got there is a real movement that we break down into frames and then play again to show the illusion of movement. With animation, we start with those frames. So we don't have an original event that we're photographing. We start with building those frames and build it up into the illusion of movement. That's really the only difference between animation and film. We'll talk about that more when we talk about animation. But everything's made up of frames when we're talking about video. Let's, for the sake of this, combine video and animation together, okay? It's all made up of frames. The frames are individual pictures that when you play them together, we get movement. So the human mind needs about 12 frames per second to discern movement. Any lower than that, and we kind of have a hard time viewing it as movement. We see it as still images, but anything over 12 frames, our brain starts to go, that's all right, I can see that as movement. So the reason for that is that it's all got to do with the time that it takes for images and data from our eyes to reach the brain. So if we can do 10 to 11 of those, it's perceived as stable movement. It's just a little thing in your brain, a little trick, a little human nature thing that doesn't really make much sense, but because of that sort of quirk, we can view movies and animation. So let's talk about typical frames per second. 30 frames per second is most monitors and TV programs. Film speed for motion pictures is 24 frames usually, but it goes up to 60 in some films. So I think The Hobbit, which came out a few years ago, had a version which was 60 frames per second. Why would they do that? It makes movement a lot smoother and clearer, but it can also make effects look more fake. By putting in more detail in, there's less motion blur. So motion blur is where an object is moving too fast for a camera to capture it properly. If you have more frames per second, there's less motion blur. So something like The Hobbit, which had a lot of battle scenes in it, can be really clear from that sort of thing. And that might be something that you would want in your animation. The higher that you shoot it as well, there's a lot more you can slow it down later, but we'll talk about that sort of thing in a second. that's probably enough for the moment in terms of frame rates. So how do we work out file size of a video? Okay, so once again, we're looking at that individual image size. So we work out the height by width in pixels. Then we work out the bit depth for each frame. Then it moves into video. We work out the frames per second. So we've got the size of our single frame, then we multiply it by how many frames per second, then we multiply it by the time in seconds, and that gives us our amount in bits. Then we can do the same calculations again, so divide by 8 bits to get into bytes, divide by 1024 megabytes, 1024 gigabytes, etc. Okay, so that's file size. Let's talk about what video formats are actually made up of. Now, this isn't expressly in the syllabus, but if you get a short answer question and you can slip this in, amazing. Okay, so the first thing about videos is they're made up of a container and a codec. Now, a container describes the structure of the file and associates with the file format. So it's the place where everything's stored within. So you would know most video files by their container name. So it's kind of like a wrapper that goes around that allows it to be played. So some common containers, WAV files, XMF, TIFFs, things like that, okay? So what they do is they combine everything together so it can be played, because a video consists of an audio file, images, and instructions for how those images are to be played back. It's not just one chunk of data, so to speak, because you need every part of the video to go to a different part of the computer. You need the image files to go to the monitor, you need the sound files to go through the sound card to your speakers, and you need to go to play it back in the correct order, so you need it to go to some sort of processor as well. Within that is all of the information that goes within there. Okay, so MP4, MP2, QuickTimes, MOV files, JPEGs, all of that sort of stuff. That's what goes, that's the container. All right. Now, when we talk about the codec, that's the encoding or decoding of a digital stream of data. Okay, so that's all the ones and zeros, that's all the binary in there, that's how it's organized. So codecs basically compress the data as well and decompress the data. So they use various types of modulation, which we definitely don't need to get into in here, but they use pulse code modulation or delta modulation, which are two different types of things. We use a codec in cell phones that has very low latency, which means latency is delay. So the codec for cell phones is very important. It's real time. Codecs for other things like videos, it just needs to be smooth across amount of time. So it's used inside the container. So the codec is kind of the way that everything gets put together. So H.264 is the perfect example of a codec that most people would know, especially if they've used any video programs. So H.264 is a high definition codec and a way of playing back data, and it's the default for Adobe programs at the moment. So if you go for something with After Effects and you export it, you'll use the H.264 codec. But the file that you'll have will be a .mov file, which is a QuickTime file. Container, MOV, codec, H.264. H.264 is like the code or the language that it's written in. The codec, that's the codec, and the wrapper is the QuickTime file, which is how you can play it. So let's talk about some video file formats. So you've got MPEG, which stands for Moving Pictures Expert Group. It's pretty standard these days, so there's the different versions of those. So at the moment, MP4 is an example that we use of an MPEG. It gives you high quality video at small file sizes. It's cross-platform and it's supported by almost everyone. So you can play it in a web browser, which is really important at this point. Some video formats, especially older ones, wouldn't allow you to do that, and of course that's very problematic in this day and age. But it uses lossy compression. So once we make an MPEG file in that way, we can never get back to that, okay? AVI, audio video interleave. So that's an older file. It was introduced by Microsoft a long time ago, I think back in the late 90s, maybe early 2000s. It was special because it was one of the first consumer file types to allow audio-video synchronization for playback, so it made video actually doable on a computer. It's relatively low quality though these days. We don't really use it because of that. QuickTime was invented by Apple, so the .mov file, it's also quite old at this point, but Apple's still clinging on to it because it's an Apple product. They like doing that. It's pretty good because it's a popular format at this point, but you need QuickTime Player to play it pretty much. And I mean, it's on most computers at this point, but you could consider it a disadvantage. I'm pretty sure you can play QuickTime files on VLC Player, but don't quote me on that, and don't comment me if I'm wrong, because I honestly don't care, okay? MPEG-4 is a further compression of the MPEG format. So it was originally, I'm pretty sure, showing up around the time that mobile phones were showing up, and we needed really small file sizes. It allows us to put in intellectual property management on it, and it's just more efficient. So that's pretty good. Commonly used to store digital video and audio streams, and it allows streaming over the internet, and that's a big one. So if you've ever streamed a video, maybe like, well, I know like a lot of the illegal streaming videos are MPEG-4, but maybe Netflix videos as well would be in there. Don't quote me on that again. I don't care. Yeah, that's your MPEG-4. So your MPEG-4 is a pretty important file type at this point. You could bring in the QuickTime MOV as well, and you could even chuck in AVI if you ask for 3 examples of video files, and you'd be fine. Moving on, and let's stick to the actual syllabus here. We want to talk about video editing. So importing video, exporting video, all of that sort of stuff. Okay, so in most programs, when you import a video, the way to do it is to go File, Import File. I'm going to use Adobe After Effects and Premiere as my examples because they're the video editing programs that the people in my school have access to. So it's best not to just drag and drop your video files into something. The reason for that is because video files work much in the same way as image files do in InDesign. You need to keep them in the same place because you're not actually loading the video into the file, you're just creating a link to that file. When you move the video file, it goes missing in your After Effects folder. You get a multicolored bar screen that says it's missing, and you got to go find it. There are ways to get around that, so you can go and create a dependencies folder, and then that creates copies of every single video that you have used in the program as to that point, puts it all into a big folder, then you never have to worry about moving it again. But it's usually best practice in the first place to just do proper file management. So dragging all of your movies that you want to edit or the animations that you're putting together and putting them all into a single folder with the project file, then you won't have a problem with that. So if you're importing something in, you really need to have careful file management, or you're going to have a bad time later on. To export a file, and we're going to use After Effects as an example because it's the one that you guys would be most familiar with. You want to go composition, add to render queue, and then you sort out your codec, your container, where you want it to go, your quality and all that stuff, and then you just hit render on it, okay? So a render process changes a file from a working file to a final file. What's the difference between a working and a final file? Well, a working file is usually not watchable unless you have all of your source footage. It may be of a format that allows editing, keeps your layers together, all of that sort of stuff. An exported file is a final file that can be viewed by most people on another computer without having access to your source files. It can't really be edited without taking it into an editing program and cutting it up, but you don't have access to those layers anymore. Think of it like this. A final finished file is when you're done, when you're finished. A working file is one that you're still working on, and you should be fine with that. I think for the moment we're going to cut it there, and we're going to move on to talking about video editing, and maybe we might even